In this video, we're going to solve some integrals together. So let's get started. The first type of integral is when you have something like this with some sort of exponent. Here's how we solve this. In order to keep this thing very simple, let's not waste time with the integral signs and all that, and just focus, just for clarity purposes, just on how to solve this. So let's get going. So the way for you to solve these ones, it's always the same principle. It's what you have in the initial exponent, when in this specific case is 1, plus 1, it's always plus 1. And then down here, what you have here is the same thing that you have here, and it's going to go down below. So you're going to have 1 plus 1. So what this means is x, the integral of this, it's x 1 plus 1, and then 1 plus 1, which in our specific case, it's x squared divided by 2. Okay, let's solve another example. So let's say now we have x squared. By the same token, we're going to do the same thing. So x, we have 2, so 2 plus 1. All we have here goes down here, so 2 plus 1. So the result is x, 3 and then 3. Okay, let's do another example. So let's say we have x 100. You asked to integrate this one. It's the same thing. So x 100 plus 1, and down here the same thing. So 100 plus 1. So the solution is x 101 and then 101. Okay, let's keep going. One thing that is important to know when solving integrals, it's about the constants, and sometimes constants get in the way, so it's important to get them out of our way in order to solve the problems. Here's an example. So let's say you have something like this, 1.5 x dx. The first thing is to get this guy out. So what we're going to have here is this x dx, and now we can go back to how we were solving this before. So we have 1/2 and then x, so x squared divided by 2. So in the end, the result is 1/4 x. What about if you have this one? X and then square root. How do you solve this one? An important rule to remember is that the square root, this is the exact same thing as having this one. 1 is inside, and the square root, when it doesn't have any number in it, it's the same thing as having 2. So let's say you have the square root of 4 and then 3. This is the exact same thing as being presented this one and this one, it's the exact same thing. So let's say you have something like 100 outside, and then in the inside you have 9. So this is the same thing as having 9 divided by 100. Okay, so now that we have this out of the way, let's solve some problems with square roots, because these appear quite a lot. So let's say you're asked to solve the integral of this one. So what we are going to do here is use the exact same principle that we have just shown here, and use the same properties that we used before in order to solve integrals. So this is the same thing as having 1.5, and in order to solve this, it's the same thing. So 1.5 plus 1, and plus 1, notice that you can have 2 divided by 2. So this is the same process. And in the bottom, you're going to have the same thing that you have here, goes down below. So 1.5 plus 2 over 2, which is 1. And then let's keep going. So 3 divided by 2, and then 3 divided by 2. Now that we have a fraction here, this is the exact same thing. Let's continue here. This is the exact same thing as multiplying by 2/3. So you have 3 divided by 2. All we are doing here is we are changing the terms. This is the exact same thing. So we have 2/3, and then we still have this element here. And as we've seen here, in order to make this like in a square root fashion, you're going to have this one, and then this is x to the 3rd power. And then because this is squared, you don't show the 2 here. You could put it here, but as a convention, you don't show it. So this is the answer for this one. Let's do another one. What about this one? So let's say you are asked to find the integral of this one. So we are going to do the same thing as we have been doing before. So it's 3 divided by 4. Remember, because this one comes here, so we get rid of this square sign and get this like in this form. So now we're going back to the same procedure that we have been doing so far. So 1, since we have this one divided by 4, is 4 divided by 4, which is 1. 3 divided by 4 plus 4 divided by 4. Then this is x 7/4. Then this is 7/4 again. And now we're going to use that property. So 4 divided by 7. And then we have x 7/4. Let's continue here. And now we're going to use the square root fashion. So we have x, and on the inside it's a top 1, and the bottom 1 comes outside. So this is to the 4th, right? So let's keep going. So let's solve another one. What about if you have something like this? Just to hit the point home. You have x 48, and then you have 500 outside. How do you solve this one? It's the exact same thing. So forget about the big numbers. It's about the way that you solve this. The algorithm is the exact same thing. So let's get rid of the square root symbol and get it in a fraction mode, because it's easier to work with. So all we did is got this one here, so we could get rid of the expression. So we have this one right now. So all we are doing is the same thing. So 48, if I can write, divided by 500, plus, because it's 1, so it's 500 divided by 500. Divide the whole thing by this whole thing. So 48 divided by 500 plus 500 divided by 500. So doing the math, this is x 548 divided by 500 divided by 548 divided by 500. So now we're going to exchange these terms in order to get them on top. So this is 500 divided by 548, and then we have x, and now we're going to do the same thing in order to get it into a square root form. So the top one stays inside, and then the other one gets outside. So this is the solution to this expression. What about when you have negative ones? With the exception of 1 over x, or x minus 1, where the integral is ln of x, with this only exception, the other ones are the same process. The other ones we use the same process to solve. So let's say we have x to the squared power, or it's the same thing as having x minus 2. So the way for us to solve this is the exact same way as we have been doing before. So x, you're gonna add 1, so minus 2 plus 1. So this is x minus 1, this is minus 1. It's the same thing as having minus 1 over x. What about this one? So let's say we have, let's change colors here for a bit. So let's say we have 1 divided by x to the 3rd power. This is the same thing, so x comes on top. Because this is positive here, when you present the expression this way, this becomes negative. It's the same thing if you had, like, if this was negative, if you wanted to do the same thing, this would be positive. This is the exact same thing. It's just a different way of showing the expression. So if you are going to do this, when we have x to the 3rd power, now we have x to the minus 3, and we're using the same expression, the same system that we have been using before. So minus 3 plus 1, because the same terms here. So x minus 2 is the same thing. So we're going to have minus, and then this comes below, 2x squared, right? Let's do another one. Use a different color here. So let's say now we have 1 divided by x to the 4th power. Feel free to pause the video and try these for yourself. We're going to solve these together. Just, it's important sometimes for you to try to figure out things on your own first and then come up with questions, because understandably they're going to appear. So this is the same thing. So this is positive here, so it becomes negative. And in order to solve it, we're going to add 1. And in the denominator, we're going to do the same thing. So minus 4 plus 1. whatever you have here, it's always the same thing down below. So x minus 3, and then minus 3. So you can get this one in the middle. So minus, and then you have 1 divided by x to the third power. All right? What about this one? So let's say you have 1 divided by x to the fifth power. It's always the same thing. So if it's positive down below, like we have here, we can get it on top as negative. So x minus 5. And in order to solve this, we already seen that you just need to add 1. And in the denominator, you're going to get all this stuff here, the same thing. So minus 5 plus 1. It's the exact same thing that is on top, just getting it at the bottom. So x minus 4 divided by minus 4. This is what we have so far. So now we can get all this term down below. And we are going to get, and this is, remember, this is multiplied by 1. And at the bottom, you're going to have minus 4. We haven't changed anything. And now we have x to the fourth power. What about this one? So let's say we have the square root of x. But now the whole thing is raised to the minus 1 power. How do you solve this one? Remember that the rule is always the same. If this is negative, this is the exact same thing of having the whole thing down below as positive. The exact same thing. And we have seen that the square root is the exact same thing as having x over 1 divided by 2. So all we are doing here, essentially, if we have this, and because this is positive down below, we can present the same expression like this. So x minus 1 divided by 2. This is the exact same thing. And now we can solve it as we have been doing the other ones here. So plus 1 in our specific case. You can have it like in the same denominator that we have here. So 2 divided by 2. All the stuff here is the exact same thing down below. So minus 1 divided by 2 plus 2 divided by 2. So this is 1 divided by 2, 1 divided by 2. And because we have a fraction here, we've seen before, we can exchange it and get it on top. So this is the same thing as having 2 here, right? Because it's 2 divided by 1. And because this is 1 divided by 2, this is the same thing as having 1 and then the square root. So this is our answer. What about this one? So let's say now we have this one. We have the square root, but now it's negative and down below. So how do you solve this one? This is the exact same thing. Remember that in algorithms, in any type of way of approaching things to solve them, you need to make sure that a step is correct. You might not have all the answers like to the further steps, but you can make sure that this is correct. It's like saying 2 plus 2 equals 4. Same thing here, so we are approaching this from a perspective of trying to simplify the expression. So we are looking at this term here, and we notice that this is negative. So we can present the exact same expression as square root of x, and this comes out on top. And because we have 1, this is the same thing as multiplying 1 with the square root of x. Because we had it negative down below, it's positive on top. So now that we have this in this form, we have seen how it works. So this is going to get rid of the square root sign. This is 1.5 plus 2 over 2. Then 1.5 2 over 2. So this is the same thing as having 3 divided by 2. 3 divided by 2. And now it's the same process. So we change the terms so that we can have this one here. So 2 divided by 3. And then we have x. And this one, it's the same thing. So we have this one, we change the terms. This one comes on top, and this one goes there. So x to the third power and the square root. This is our answer. What about this one? So let's say now we have 5 divided by 3x4. So how do you solve this one? Same thing, always use first principles. We notice that we have a constant here, which is 5/3. And saying we have 5/3 multiplied by 1, nothing changed, right? Because it's still 5/3. So what we're doing here right now is just getting rid of this term and putting it in a way that makes it easier for us to solve the expression. So we have 5/3 multiplied by 1 divided by x to the 4th power. And as we've seen before, we can change this expression in a way that is more workable for us. And because it's positive in the denominator, we can change it to negative in the numerator. So it's the same thing as having x to the -4 power. So now we have this in a way that it's more workable for us. So we keep the constant, and the same as before, we just add 1. So -4 plus 1, and down below we keep the exact same terms here. So -4 plus 1. So let's keep going. So 5/3 x minus 3, and then -3. So this is the same thing as having x minus 3. We have 3 times -3, that's -9. And then because we have this negative, we can get it down below. We use the sign because it's negative, we get it here. So it's -5 divided by 9x to the 3rd power. What about this one? Let's complicate things a bit in order to really hit the point home. Like I said, forget about the signs, about the integrals and the dx's and all that. Later on we can get to it. The critical point for you to focus in is how to solve the expressions. So let's consolidate our knowledge with an example that has all the things that we have been talking about here. So let's say we have 5, now we have 3 here, then we have 2, and then we have x to the 3rd power, and this is the square root but with a 4. How do you solve this one? So same as before, look at constants that we can take outside and remember first principles. So what I mean by this is when you have 5 or you have 5 times 1, it's the same thing, right? Still 5. So here we can take this element out and these 2 elements out and leave 1 inside. How do you solve this? We have 5, right? Divided by, we are multiplying by 1. We have 6 here, right? And it's multiplied by 1 divided by x to the 3rd power. And the square root is 4, right? We haven't changed anything. We still have a 5. We have a 1. We have 3, 2. So 3 times 2 is 6. We have 1 here, right? Now we can focus on this element and focus on solving it as before. So we have 5, 6 here, times, we're going to separate the elements. You're going to have 1, and then 1 divided by x to the 3rd power to the 4. And now, as we've seen before, because this one is in a square root form, we can change it. So let's do that. So we have 5, 6, we have 1 divided by 1, and then we have x to 3 divided by 4, right? And because this is a fraction, right, we can get this, like get rid of the 1, solve this in a way that makes it easier for us to solve. So still 5, 6, we haven't changed anything here, still have 1. And now because this is positive down below, it gets negative, but we have the advantage of getting rid of at least one of the parts of the fraction. So we have one less thing to worry about, right? Keep in mind that this is 1, we haven't changed anything. If this was 5, we would have a 5 here. If it was a 10 or 11 or some number. But because we just have 1, we are multiplying 1 by this term, right? And now let's keep working on this element. Because this is negative and it's in the denominator, we can get it on top as positive, right? So change colors here. So you're going to have 5, 6 times, we're going to have all this term coming on top and get rid of the negative sign. So you're going to have x to the 3rd power divided by 4, right? And now we're going back to the same way of we have been solving these problems. So just going to add 1. So we have the same denominator. So we're going to use a fraction that's it's workable with between both terms. Get both these 2 guys down below. So 3/4 plus 1. So you're going to have 5, 6, x 7 divided by 4. and then 7 divided by 4. So the solution to this, let me just get rid of this part on the top. So we have 5 divided by 6 times, we get this constant, we get it on top and change the term. So 4 divided by 7 times x 7 divided by 4. So 5 times 4 is 20, 6 times 7 is 42, and now because we have this, we can have it in a square root form. So it's the same thing as having x, 7, and then 4. You can even further simplify this because this is divisible by 2. So it's the same thing as having 10, 21, x, 7, 4.